Hi, today I'm going to replace a BGA graphics chip on a MacBook Pro board, and I'm going to show you as much as I can from start to finish. One of the things that drives me nuts about almost every BGA rework video on the internet is that they are all done at 10x. They are all done with shitty techno music playing. They're all done with like your grandpa's 1979 Betamax $200 camcorder that looks like crap. And as cool as it is in terms of, a dick waving contest of, wow, look what I can do, most of them are not actually helpful. They don't show you the process. They don't explain anything. And in my personal opinion, a lot of them just suck. So let's get started. So the first thing that I do with all these boards is they actually go into an oven like this. I got this thing at Kmart. What this thing does is it gets rid of any of the moisture and the nonsense in the boards. So as the board is sitting in a repair shop or sitting in somebody's house, depending on where you live, it could build up moisture over time. And what the moisture happens to do is it causes things like popping and bubbles in the solder, delamination where you see the board getting these little bubbles on it or the chip getting little bubbles on it. And what that means is that the chip is just completely destroyed. And BGA rework is not like a lot of the other jobs we do. It takes a lot of time, a lot of effort. So if you do one thing wrong, you mess up 40 minutes to an hour of work and $50 in chips or $500 in boards. So it's really worth it to just toss it in something like this. You're going to hear a lot of differing opinions on it, but since this oven was about, I don't know, like 50 bucks or something and maybe 100, and this takes me 2 hours of time with it, I don't even have to spend working. I'm happy doing it. Again, if I have 10 boards in the list that I have to do today, I can say, okay, 2 of these are GPUs. I'm going to take them out and put them in the oven. I'm going to do the other 8, and then I'm going to come back to these 2 later once it's done. Again, it doesn't actually take work or effort on my part to do this. So I'm going to remove these, and I'm most likely going to forget that the board is boiling, so I'm probably going to curse a little as I'm taking it out. Let's see if I can... I'm going to use a paper towel here as an oven mitt. This is just a god-awful idea. So, yeah, you really should come up with a smarter way to do this than the BS that I'm going to be doing right now, because this is crap. This is not how you should do it. All right, so I'm going to take this board out like this. Oh, dear God, I shouldn't be doing this. And one of the things I'm going to do while it's still hot is remove the underfill here. Alrighty, so let me show you what I mean. I actually used the wrong word. I didn't mean to say underfill. I meant to say edge bonding. So there's this thing called edge bonding on the GPU. I'm going to zoom in on it right now so you can see what I mean. And the purpose of this stuff is supposedly to keep the GPU from moving around and to keep it from damage and, all sorts of stuff that in the real world it doesn't actually do. Alright, so see? Oh, yeah, that's a cool camera picture. I mean, I don't know how it looks to you, but at the very least, in this little 1-inch LCD on the camcorder, that looks pretty damn cool. Alright, so what I'm going to do is I'm going to remove that, and the reason I'm choosing now to do that is because the board is already hot. The whole thing is already hot, so I'm hoping that it's going to be a little bit easier than it would be if the board was not hot. So, just grab some tweezers. I'm waiting for my hot air station to get hot. One of the things you should know if you're doing this and you have one of those boards that is red with the red edge bonding is that stuff, when you heat it, oh my God, it smells awful. I mean, it's just the worst shit that you will ever smell in your life. It is disgusting. It's terrible. It's garbage. And it's just really, really bad and nasty. Alright, so I'm just going to heat this slowly. Here's where you can see my iron there. Not iron, rework station, I guess. Hot air gun. Now, I don't want to destroy it. See, I actually did start destroying it already. Oh, well, because then it comes off nasty. You just want to heat it enough that it becomes rubbery so that you can just... There we go. I guess I got lucky. Usually that doesn't happen. No sex jokes. I know I gave you an easy opportunity there. Alright, we're going to get the next one. This looks so cool in this little LCD right here. I mean, I'm going to wind up crying when I see what YouTube does to this video. I wind up crying when I see what YouTube does to almost any one of my videos, actually. I mean, like, to see how good they look, and then to see just what they actually wind up doing to it, it really does make me sad. Also, one of the things you don't want to do in this process is knock off resistors, because that's bad. Like, see, I have tons of boards I can compare to. So if I mess up and I knock off a resistor, whatever, I can find it. But if you don't have a lot of boards to compare to when you knock off a resistor, well, then you're screwed. Also notice, you may notice that this is coming off easier for me than it is for you. That's because I had the board in an oven for a couple of hours at around, I think, 250 Fahrenheit, 240 or 250 Fahrenheit. So I mean, it's not just that this stuff has been baking for a while, this nasty rubber nonsense crap. It's also that the board itself under is actually hot, the adhesive is hot, everything's hot, which makes it a lot easier for it to come off. Notice also I said that it's easier to come off right as I got to one that didn't come off in one piece. Such is my luck. And we're almost done here. So we're going to get this next part off. Alright, the board doesn't want to stay still. Don't knock any resistors off. Be super careful. Especially since with this camera and this zoom, I know you guys are going to see if I knock any of them off. And you'll never let me hear the end of it. Mofo. Stay still. I should have just taped this to the table, but by the time I get up to get the tape, this will be done. Alright. Now, the second thing that I'm going to do before we get this ready for any type of VGA rework is prepare the VRAM. Hot, 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 hot. Go away, plastic junk. Oh my Jesus, this is hot. Okay, anyway. So, you see how there's this edge bonding as well around the video memory? There we go, it into focus. So that edge bonding is going to destroy our process because as we're heating to remove the chip and also to put the new one on, that stuff's going to start melting. It's going to go underneath the video memory, and it's going to get under the balls of the VGA memory, and it's going to be a nightmare. So what I do is I put some tape on here. Now here's one of the considerations when putting tape over this. One of the first considerations you should have is that Kapton tape is very often not that great for soldering. I know I've shown it in other videos, and I just want to talk about what I mean a little since I may seem like a hypocrite. What I've been finding with using Kapton tape is that very often the little components around will actually come off. So I mean, if you put Kapton tape on a component, if it gets desoldered, it winds up not really getting soldered back to the board very well when it cools, and it sticks to the Kapton tape. So when you peel the Kapton tape off, all those little components come with it in a very, very nasty, violent fashion, and I don't want to see that happen to you. So, my recommendation, personally, is to use a different type of tape. Now, I wish I could tell you where to buy this, but unfortunately, this is just one of those things that's already here. Here it says Nashua tape. So yeah, this is Nashua tape, HAKKO adhesives. Yeah, I'll zoom in on this crap later. Now the thing is, it's this nasty ass aluminum kind of tape. It is nasty. So when you put that on there, that adhesive, especially after getting heated, it never comes off, and it leaves a really unprofessional look around the board. So one of the things that I'm going to do is I'm going to cut it so that I have enough that's covering this whole region, but I'm not going to actually tape it. There's paper underneath this tape, and what I'm going to do is, I mean, I might as well, while I zoomed out, show you the tape, what it says on the inside of it. Alright, so anyway, if you take this stuff off, it's going to be nasty. Like that adhesive, when it's disgusting. It's just gross. So what I'm going to do is put this like this, cover the VRAM that I want to cover, then I'm going to fold it over the other side of the board. I'm going to cut this a little more because I don't need it to come out as much as it is. Alright. So I'm going to protect the VRAM, but without getting this nasty ass shit all over the board. Because I don't want this nasty ass crap. You have to see it to really understand. But that is glue that you can wash your hands for half an hour. That crap is not coming off. So we do this. And just to secure the tape, I'm going to use a little Kapton tape. But I'm not going to attach the Kapton tape around all these tiny components. Again, if you attach Kapton tape to this motherboard, This is something you really should learn early on, because I've seen many people fuck this up, and it is just sad, very, very sad when you watch them come over to you and say that they've ripped every component off a board. You see all these little things over here? If you put Kapton tape over all those components and then start soldering around it at very, very high temperatures with something like the BGA machine I'm going to use, they're all going to come off. And like when you take the Kapton tape off, all those little things are going to come with it. So I'm going to use some Kapton tape here. And everybody has their own way of doing it, and the way that matters is the way that works for you. It's not the way that works for me. I'm doing this video not to show you the right way to do it. I'm showing you something that works for me. So I'm going to Kapton tape this to this big inductor, because I know that that is absolutely not going anywhere. And I'm going to Kapton tape this a little bit on here, on the bottom of the board, which you can't see because I'm a terrible cameraman. There we go. And again, this is, by all means, you're going to find your own way to do this. You're going to find your own way to do all of this. So, and when it works and makes sense for you and it makes money, you're not going to give a crap how I do it. I'm just showing you a way that works for me. And then I secure it over here on the other side. And I'm going a little overboard with it, but I'd rather do the extra work now than have to touch that crap later. It is disgusting. And if you're going to get handed back boards someday that have that adhesive on them. It's just some nasty, nasty shit. Okay. So my VRAM is covered like this. The other thing that I'm going to do is cover up the LVDS mux a little bit. Now this is me just going out of my mind and batshit insane. You really don't have to do this, but that is a chip with 0.25 millimeter balls. And if you mess up that chip, you are in for a whole level of misery in life. So I don't want to reflow the mux. I don't wish that on anybody. The LVDS mux is right here. And I'm going to cover that with this because I don't want to reflow it. Again, nobody watching this video deserves to have to service that chip in any way. It is nightmarish hell that I don't wish on anybody. So this is my board preparation process. And I don't feel like sticking that stuff on there because I just don't feel like cleaning it. If I touch that, I'll be ugh. And I'm just going to tape it. Let's see, where can I tape this where I'm not going to... There. You don't want that glue flowing onto the mux either. Now I'll just tape it to this little chip that's next to it, and I'm not really sticking to any of the little resistors. And on the other side I will tape it straight to the board. No reflowing the mux. No fucking up the mux. So this is kind of what you get at the end. Okay, now let's move over to the machine. Alright, and I'm going to show you the desk even though it's disgusting. Because I value my fans that much. So this is my desk. It is nasty, it is gross, it's terrible. I do need to clean her up and just give the whole area a general makeover. As usual, too busy. So, what comes up next? My board. We're going to place it on here. And we're going to turn on the machine. this would actually make some sense if I got the camera closer. Let's get... Alright. Good. Okay. The camera is going in the bathroom. I'm sorry, camera. I know you don't like that very much. Drywall compounds. That's exactly what you want right behind the door to your bathroom and near your BGA rework station. Bunch of drywall compounds. Alright. So, zoom out as much as I can here. Alright. Great. I have to do this. Alright. So the first thing that I want to do here is get this situated so that when this goes all the way down, my nozzle, I can't take this seriously when half of my head is missing. Here we go. So what I want to do is I want to get it so that when I bring the nozzle down, the GPU is pretty much even on every side of it. So I'll show you once this is positioned the way I want. Yeah. There's a little stud that goes right by the bottom nozzle that, there we go, that props it up, but is unfortunately the wrong length up. So. Alright, now let's try to get this to make some sense. Alright, so once you got that even, let's take a little zooming look over here. I'd have to put the camera higher to show you exactly. You can trust me that it's even. The next thing to do is to set up this camera so that you can see the balls underneath the chip. Try not to laugh. We have a thing here where we simply we lack the capability to not laugh when we talk about balls dropping or any of these things, and it really is a bad habit that I hope that we can get over. You have to position the camera so that you can actually see underneath the chip, so you can see the balls, so you can see when they melt. Now, one of my personal pet peeves with all of these systems is that the camera is this, you know, again, if you think the 360p videos on YouTube are bad of BGA rework, just look at the fucking camera systems. This is just or shit. Alright, so you want to get a view of the balls so you can see when they melt. So, you see what I got on the screen here? One of the things that drove me nuts before I knew how to set up the camera right is I would look on these videos and think, my camera's not as good as everybody else's. I got a knockoff camera. This is BS. Mine doesn't look good. You just got to learn how to set it up. So just put aside a day. Know that for a day you're going to be fucking with just setting up the camera so that you can see this shit. And that's really that. Alright, now, Next things, fume extraction. So in my bathroom, again, this is the most professional BGA rework environment you will encounter. In my bathroom, right behind here, there is a window, and in the bathroom there is a fan that is exhausting the air. So this is good, you know, if you have employees that eat the wrong food at work every now and then, and it's also good for this. And I've also got this HAKKO FA430 fume extraction system here, which I'm going to set up because I don't want to smell this shit. It's nasty, it's gross, it's disgusting. I don't like the smell of solder and flux very much. So that's what I'm going to do over here. And then I turn this thing on. It's loud as hell, is what it is. Now for the machine. Let's focus on setting up the machine. Let's show you how this thing works. Yeah, show you some profile, show you some action. Alright. So this machine, I'm pretty sure this is Windows CE. Windows CE is disgusting. It makes me sick. I hate Windows CE. But again, this is, even though this is like a $7,300 machine, this $7,300 machine is like a knockoff of some other company's $25,000 machine. And even if you buy the $25,000 machine, I'm pretty sure that they give you Windows CE, which is bullshit. But it is what it is. Alright, so let's get the camera focused on this screen. Again, I really don't want this to be one of those videos where everything is, you know, 360p and blurry as hell and they leave out all the interesting parts. So, alright, so we're going to do operation. This wooden sticks here for the touchscreen. The touchscreen on this is like total, look at this. It's shit. Like, see, wooden stick. A stick is your friend. So, here's what we're going to do here. Operation. We're going to load a profile, right? So, VGA select. Okay, I want A1286 lead free. Here it says 81286 because the guy originally programming it, when I was saying A1286, he thought I meant 8. Yeah, here's what it is. Now, I might as well show you. You can see the profile, and you can see what all this crap means here. Alright, so you have the temperature, the time that it stays at that temperature, and the slope at which it rises to the temperature. So you have temperature in the beginning, 50 Celsius. Stay at 50 Celsius for 90 seconds, and get to 50 Celsius at a slope of 3 Celsius per second. That's what that means. And you have bottom temperature, so there is a bottom heater on this machine. The bottom temperature should be at 125. Stay there for 90 seconds, and get up to there at 3 degrees per second. Now you have IR temperature. That's the temperature of the infrared heaters in the bottom. The infrared heater, go to 200, stay there for the duration of the profile, which is 300 seconds, and you have to set this thing up. It really does take time to set it up so it works for you. So let me try to get a view where you can see everything from the balls to the profile running all in one view. If I had multiple cameras, this would be really cool, but I don't. Yeah, I can't make it so you can see everything. Oh well. Maybe I can. Let's see if I can try. Let's see. What can I do here? Okay, so this is a good compromise. I think you could see a decent amount from over here. And the best part is you don't have to see me, which is perfect. So, now one of the couple of the cool things about having a hot air station is the ability of control that you have over it. If I think that firstly, I like having the camera so I can see everything. One of the things I hate about seeing soldering setups or BGA setups where you cannot see anything, I need to see what's going on. I want to see the balls melt. I want to see if there's not liquidus when I'm going to pick up the chip. I want to see when I'm soldering the new one. Did the profile stop before these ones became liquidus? This is something that I want to see. So don't be a cheapskate. Invest in a camera. This is important, and it's going to allow you to be able to work based on what you see, and it's going to allow you to operate this manually, because all the profiles in the world and all the people helping you and telling you how to set it is not going to mean shit if what you see here or what you don't see here is not actually happening properly. Now, I like being able to see everything. I also like, okay, let's say I'm at the end of a profile and something's not going the way I want it to go. I can just, I can just move the nozzle in closer. On an infrared station, when you move the nozzle, no joke, if you move the thing from here to here, or like from here to here, you will see PV, which is your temperature on most infrared stations. You'll see that thing go from like 215 to 300 in a second. It's like the control that you get with infrared is just... Again, it's a personal preference. A lot of people prefer infrared. A lot of people prefer hot air. I'm not going to say that one technology is better or worse than the other. I'm saying that my preference, personally, if I had to choose what to use for myself, I would choose hot air. So, we're going to start here. And we loaded the profile. I hit start. And I'm ruining. Not running, I'm ruining because people who didn't speak English programmed this. I hope I'm not ruining. I would like to think that I'm fixing, but we'll see. So we have 3 heaters here while the profile is heating up. We got this thing over here, that's the top heater. We have the bottom heaters, these big black things. These are infrared heaters, and which heat up just it keeps this entire area in general warm. And then we have the bottom heater directly underneath the chip, which is heating the area of the board directly underneath. So this is a 3-zone machine, which is pretty cool. Now, on this profile, again, I'm going to show you a bit of the profile. I'm going to be moving this back and forth a little bit every now and then. So on this profile, the way it's working is the top heater is staying at 50. The top heater is not actually doing anything for the beginning of it. You see? I guess I might as well focus on this for now. There's really no reason to focus on the balls because they're not going to melt for a while. So the red is the top heater. The green is the IR, the infrared heating. And the yellow is the bottom heater. So the way this profile works is the top heater is not going to kick in until the very end. The idea behind this, when you're soldering a new chip, what's the point of putting the heat on when you're not at the point that you actually want to solder? The top heater is there just to finish off the profile. The top heater is not there to actually do all the work. So the first things first is the board has to soak in some heat. So that's what's happening right now. The infrared is going to slowly rise to 200. Once it hits 200 and it's been there for a while, then they're both going to ramp up a little bit, and then you're going to be at a higher temperature. And once you're at that higher temperature, a few seconds later, you're going to see the profile go ring, and that's at the point at which it is removing the chip from the board. That's the point where we're going in for the kill. So alright, so the suction cup that I thought I had, I don't. I can't use the machine to pick up the chip because on this thing, there's no rubber grommet right around the part that picks up the chip, so it's not going to work. So even though the thing cost a lot of money, one of the things that sucks about it is that there is no there is no rubber grommet around the metal piece. So the way they ship it to you, you really can't reliably use this to actually pick up the chip. It sucks, but is what it is. Now, since I don't have the things that I need, I'm actually going to be trying to pick up the chip using tweezers, which is something that you should never do. But I already started the profile and I'm halfway in. And as is usual, since I'm doing a video, nothing that I want to show you will actually work right. So pay attention to the solder balls. Pay close attention. We're at a top temperature of 211, which means the chip underneath is probably 190, which means we're about 20 Celsius away from a point where we're going to see melting. Hopefully you can see solder balls from here. This is a camera recording a television, which is showing a camera, which is just a complete piece of shit. So, okay, we're at 216. Now we should be ramping up to the next stage in just a second. Going a little closer. Okay, we're at a top temperature of 250 Celsius. One of the balls just started to become liquidous. Those are still cold though. Go in a little closer. Okay, we're almost to the end. Hopefully you can see that these have been, see how shiny that is? We're just about done. And the machine actually picked the chip up on its own. That almost never happens. I'm not kidding, that never fucking happens. But I can't complain. So now what I'm going to do really quickly while this is still boiling hot right now is do a little bit of preliminary cleaning on the board. I'm not going to do my complete cleaning. Oh, lovely, you dropped the chip on the board. That's just great. Luckily, it dropped onto the inductor. Fuck you. So I don't have to care too much. Anyway, while the board is still boiling hot, I'm going to take advantage of this a little bit. And I'm going to clean it a little bit. One of the biggest pains in the ass is cleaning this board, since it has lead-free solder on it. And while lead-free solder has its uses, you know, plumbing, stuff like that, it's not the best when it comes to electronics. It's just not the best for rework. I'm not saying as bad as in the actual joints themselves are terribly unreliable. There are tons of debates on that, and I'm not going to get into them. What I'm saying is that it is a pain in the ass to use for technicians who are actually doing rework. Okay, so I got this big solder spool here. So I'm going to go around the site with that big solder spool. While this is still hot, probably should have started already, but oh well. Let's bring this in closer. See if there's any way I could actually get a good view for you. I do want to get a good view for you, but I'm probably going to fail because I'm in a rush to clean the soldering site. All right. This thing is hot. This is what I need. And let's get started. You're probably not going to see shit. I'm sorry in advance. This is not exactly comfortable for me either. So, we're going to go around the site and we're just going to create a ball with this leaded solder that has flux inside of it. It'd also help if I added some flux. This is not going to be the final cleaning. This is really just a preliminary cleaning. I'm taking advantage of the fact that the machine itself is hot. The whole idea here is to suck up all the nasty lead-free solder and replace it with leaded solder, because this is an easy time to do it. Because when we're actually going to clean the site, we have to get rid of all the nasty, junky old solder. All of it's going to have to go. And I just dropped a solder blob right in the middle of the board. Lovely. You'll understand when you start a YouTube channel why this stuff happens. We'll come back to that later. And SMD, lovely. Alright. Now I'm going to sit and just let it cool for a little bit. So I'm going to lower the nozzle and turn on manual cooling, which is where all the nozzles in the machine just start shooting out cold air. I'm going to leave it like that for a little bit. And while I'm doing that, I might as well clean up the mess that I made. Anytime you make a mess, you should clean it up. That'll be easier to clean up the rest of it once I'm on a table. Alright, I'm no longer capable of burning myself. So time to get started with the cleaning process. So first things first, I'm going to change the tip on this to something that's a little bit more appropriate for what I want to do. Oh, well. If you hear that beeping in the background and you think it's annoying to you, I assure you it's 5 times more annoying to me. I don't know why HAKKO made it do that. Like, the whole constant beep thing is really, really unnecessary. Like, chillax. I put you back together. Alright. Now we're going to take one of these absorbing things and put it over here. Move this microscope aside because I don't have one there to use. And start some board cleaning. Okay. This is an important thing to get set up the way you want before you start, because you don't want to inhale any of this stuff, because it's absolutely disgusting. It is nasty, nasty shit. I cannot wait to move this setup into a different space. Oh boy. So, let's get over here. Let's get some zoom going on. You can see what's going on. See the cleaning. I think I could do better than that with the camera. Let's try. All right. So you get some solder wick like this. Solder wick is something that sucks up the old solder. And it's going to be a lot easier to do that when you have some leaded solder on there instead of lead free. Slow is fine. Oh, this hose is just screwing with me. Terribly screwing with me. I'm going to get the other one over here because I want more. Alright. Whoa. That is nasty shit. Okay, cut another piece. Go over again. Where is the camera? Here we go. We're at a point where the board is fairly clean. But unfortunately, the combination of flux and also the nastiness from this wick is there. So let's try to remove some of that. So I have these clean room wipes from LYMTECH, Limtech, that I got on eBay, and I have this methyl ethyl ketone from the Poland Spring bottle here. This is just nasty. Absolutely nasty. I can't really show you cleaning this in the microscope because my microscope doesn't have a viewable range that would allow you to actually see. So unfortunately you're stuck with this angle, which I understand sucks, but I mean, you can get the general idea of what I'm doing. It's not really rocket science. This is just moving a piece of wick back and forth with a soldering iron, you know. Any jackass can figure this out. Bonus points if you can see the IC that the GPU dropped on. I do have to fix that. Yeah, I'm not leaving that like that. Just in case you were about to troll. Okay, now the majority is off. I'm going to switch over to the other tip, and this annoying iron is going to scream at me because... Beep! Shut the fuck up. Oh my. Whoever designed the HAKKO 951 to do that, you just deserve a kick in the balls. I mean, it's really, you just deserve to be hitting the hammer repeatedly with... hitting the nutsack repeatedly with a hammer. I mean, so why? Well, what is the point of that? Yes, I know it's off. Fuck you. Beep once, not 90 damn times. So once I have a majority of it off, I prefer this tip. This tip. Focus. All right. I don't want to turn manual focus on right now. Well, anyway, it's a chisel tip. So after you get the majority of it off, it's good to be able to focus on small parts with the flat tip that may have been missed. Also, one of the things you should know is I'm very slow at this compared to other people who do this. I'm not fast. I'm not that great. So, I mean, you shouldn't be using this video as the benchmark for your performance, because my performance is absolute just crap. Just crap. Just garbage. I am not very good at this. As I've said in many videos, the arts and crafts portion of board repair, I am not good at. The arts and crafts portion of this business in general, I'm not really very good at. I would say I'm giving myself too much credit. Alright, so I'm just going to check this under the microscope and see how I think it looks. I'm sorry that you don't get to be involved with that part. Alright, so my board's looking good. It looks like I did screw up and knock off one small resistor, which I am ashamed of. You got to get to a point with this where you're not knocking anything off. The name of this game is really efficiency. You just can't waste time with like knocking crap off and having to put stuff back on and having to reorient little ICs that you you know, that got moved away. This is really, really, really about getting as much in and as much out and as fast as humanly possible, because people truly will just choose to not fix something if it's going to take you too much time. And you will not make money if you are slow at what you do. So let's just go over some of the troublesome points that I had here. Alright, now I'm going to clean off the board just a little bit more. Gonna give it once over under the microscope. This is looking pretty good though. Yeah, one pad left. Alright, whatever. Get the one pad and call it a day. Okay, now it's time for the new chip. The new chip was in the oven. So what I'm doing right now is I got the chip inside the stencil like this. I'm only going to apply flux to the actual balls on here. I'm not going to put flux all over the board like a mess. So let me just get a brush. We got a brush. Okay. Gonna clean off the nasty old from it. Nasty old junk. Just wasted too little too much mech there. Alrighty. Now we dry it off on the other side. Okay, we got a nice dry thing. So now the chip itself is in a stencil. So what I did is I applied the stencil to the chip like this, and I looked to make sure that all the balls were visually aligned on the other side. I know, it's very hard to not laugh at this. I'm not blaming you if you are. So let me just show you what that looks like. The alignment just went off because I moved it to adjust the camera. This is why focusing on two things at once is a fail. Yeah. So the whole thing, when you're trying to align this, where are we? Alright, so right here. If you actually look at the top, it becomes a lot easier to see the balls there. The first thing you may do, like me, is look at the bottom and try to get all the balls visually aligned, but without being able to actually see the hole and the ball at the same time at the top, aligning this is going to be a royal pain in the ass. So once I've got it like this, first things first, I'm going to put the board on the machine, just to get it out of the way. Let's get Okay, good board is there. And let's focus on the chip now. So, this is my chip. Now I'm going to take some of this flux, spread it around here. I really should have gloves on for this. One of these days. Get a lot of flux all over there, and we're going to brush it like this. The whole idea here is the flux is not touching everywhere. It's only touching the balls. We're only interested in the balls getting soldered to the board. We're only interested in flux being on the actual solder balls, not everywhere like a complete clusterfuck mess. So, do this. Maybe I even add a little more. Between how many people in New York have AIDS and the Ebola epidemic, I'm just not that afraid about flux right now. Okay, now we got that part. Now let's put the chip over here and get it ready in the alignment system. And let's also hope I don't drop the chip in the stencil while I'm doing this. And hope that I don't jinx myself by the fact that I said that out loud. I've actually trapped and captured myself inside the camera wiring. Oh well. Alright. So on the machine here, which you can't see because I'm a shitty cameraman. Here we go. On the machine. On here, there's going to be something called manual vacuum. So I'm going to be turning that on. And the whole idea behind manual vacuum is that I'm going to have the chip get sucked up onto there. Which is hard because there's no rubber grommet. But it is what it is. Second thing I'm going to do is I'm going to wash my hands before I get cancer. GTFO flux solder bullshit. Get off of my hands. Alright. No open wounds, good to go. So, back to this. Now that that's on there, we're going to open the split prism alignment system, which is this. This is the difference between a $500 or $700 machine and a $7,000 machine. You get this thing. Oh, cool looking, ain't it? So the whole idea here is now on the monitor you no longer see the camera, but you see the actual chip and the board. And you can see just how terrible I aligned it when I put it on there. Right. Yeah, that's bullshit, isn't it? Alright, anyway. Okay. So one side, so obviously the blue, whatever, you guys are going to make fun anyway. The blue balls are the chip, and the yellow-brownish balls are the board. And here's what we're going to do. Now the idea when I'm turning all this stuff here, let me just show you what I'm turning. So you got knobs everywhere on this machine that I'm turning. I'm turning 3 different things. The first is this chip moving counterclockwise or clockwise. The second is this grill moving left and right. The other is this grill moving back and forth. So that's what I'm turning when I'm trying to align the chip. Because just in case you're wondering what the controls are that I'm using. It also does actually help to zoom in sometimes. Cool, ain't it? Cool toy. That's about as good as we're getting. Now we bring it down on the board. Now we're back to the view of my this camera on the side. Now I'm being very careful as I put it down there. I want to actually see with my eyes that the balls are aligned. Turn the vacuum off and go up. Now I want to get a good view of the solder balls on the screen. I want to get as many as I can. Bonus if I can get a view of the inside of them. And where's my wooden stick? Okay, BGA select. We're going to load the profile again. I'm going to bring the vacuums over here because I really don't want to smell this. Here goes nothing. In a second, we will be going away. Let's move this a little closer underneath. There. Make sure we're even on all sides. One of the things I don't want to do here is accidentally solder one side more than the other. So I'm being extra careful here to make sure that that doesn't happen. I'm a little overly cautious, but... Okay, ruining. You can see the alignment here as well. You can see that each ball is on top of a pad. Which is a good thing to see. See ball, pad, ball, pad. So watch very closely. Also, one of the things you may be wondering is I didn't reball that chip. Well, that chip actually comes with lead-free balls from the manufacturer. I don't like lead-free soldering for rework purposes. I don't like doing the actual work using lead-free solder because it's more annoying to remove, it's more annoying to work with. But in terms of quality, like when I complain about lead-free solder, I complain in terms of working, But in terms of this chip actually lasting, lead-free, that's not going to make a difference. What's going to make a difference is that this chip shares a heatsink with a quad-core Sandy Bridge, not Ivy or Haswell, quad-core Sandy Bridge processor. What's going to make a difference is the fact that the fans inside of this MacBook Pro are small and designed to get clogged with dust. What's going to make a difference is the junk thermal paste that gets used and the fact that there's no ventilation on the bottom of this machine. The solder balls really have nothing to do with why this fails. It's a crappy chip inside of a crappily cooled machine that's sharing a heatsink with a quad-core processor inside of a thin laptop. I mean, truly, this is not failing because of the balls. All that crap you're reading on forums about how this machine sucks because they use lead-free solder, every laptop for the past 6, 7, 8 years has used lead-free solder, and they're just fine. And changing the balls in the bottom of the chip, it adds one more step to my process, and it's also one more place where I can mess up. Who do you think is better at putting the balls on the GPU? AMD or me? I trust AMD, personally. And it removes one factor of human error from the equation. Again, I don't trust AMD very much to make a good GPU, but I do trust them to actually put the balls on their own GPU properly. That's not rocket science. So we're about a minute and a half or so into the profile. And we're just at the point where the bottom heater is ramping up to 167, 168. The IR is at 130 Celsius. So you're not going to see anything other than flux activating at this point. Once the flux gets around 140, you'll start to see activation of it. But in terms of the actual, the balls melting, you're not going to see any of that. Now this moving over here, this is not actual movement happening. This is what happens when you have, cheap piece of crap analog camera with coaxial output to the LCD that came for free with my Chinese knockoff ZM-R rework station. And here's where it starts to smell, even though I have the fume extractor. Boo. Flux activation. Yuck. The top heater is still at 50 Celsius. Should move that just a tiny bit. Okay. I thought I checked all this before. Just a minor adjustment. Minor adjustment. So the balls that are most in focus, I'd say, are this one, this one, this one. So that's where I'm going to be looking. Alright, so the top heater is up to 185, which means the bottom of the chip is probably at 165. We need 217 for Liquidus, which means that the top heater is going to have to be around 236, 240. So what I've noticed with this machine is the bottom of the chip, the actual temperature of the solder balls, when I had a thermocouple soldered to the ball and then ran a profile on a scrap board, is that the top heater is usually 20 to 30 Celsius behind the air that's actually underneath the chip. So right now I'm at 207, which means bottom of the chip is probably at 187, 180. Not going to see any action yet. This is lead-free. Okay, now we're at a dwelling stage. So it's going to dwell. The top heater is going to dwell around 203, 205, 210, around that area. The bottom heater is going to be dwelling around that area. The infrared is going to be dwelling, and soon it's going to ramp up. And once it ramps up, I'm going to be looking for the balls to melt. The top heater is now ramping up, so now I got to pay attention. We're at 240. So this is the ball that I'm the most interested in because I have a perfect view of the pad. Okay, I see that one dropped, 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 that one dropped. That one already did. That one's about to. And the chip is slowly aligning itself into place. The profile is almost about to finish. Okay, now we're going to wait and watch for them to dry. You can see them getting harder. The balls are getting harder. I know. It's hard not to laugh. That one, 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 that one. That's still liquidous. Camera's boiling. Alright, we're just going to let that sit for a little bit. No reason to wait and watch it. In a minute or two, I'm going to turn manual cooling on, where I lower this and then I just have it blow out air, but with the heater off, so it just cools everything off. For now, I don't want to disturb it, since you never know with solder blobs and balls still maybe waiting to dry. But in a minute. Also, I'm going to turn off this air filter, because that just makes you deaf. At this point, I'm fairly certain that every solder ball is dry. So I think it's safe to say that I can put this down and run manual cooling. Yeah. Cool it, cool it, cool it. One of the other things I want to address while I'm talking about BGA rework, while I'm waiting for the board to dry off, yes, I'm not editing this, I'm actually waiting for it to dry off before I show you the next step, is that a lot of the forums that I was on when I was discussing the next BGA rework machine to get, to upgrade from that little piece of crap that you saw next to it, is a lot of people were making really, really wise-ass comments like, you know, you must not be a real man if you're buying this, you must be making up for small genitals, this, that, and the other. And the thing with my business is, we have a very high volume of these to do. We have a high volume of boards to fix. And anything that I plan on doing, my business is kind of like a locomotive. I mean, I start slow, but with this one idea of just moving straight forward with it. And I intend to be moving at 100 or 200 miles per hour, you know, very soon afterwards. So anything that I start doing, I really do plan on building on it. So if I plan on doing board repair and learning it, I plan on getting 5 or 10 or 15 of them a day. If I buy a machine to do this kind of BGA rework where I can focus on the machines with these dead GPUs, I plan on advertising to the board and getting 5 to 15 of them a day. And one of the important things to me here is that the process is repeatable, that I get the same results every time, and that I minimize user error, that I minimize my error, process error. And it seems like a big investment up front, but again, my goal is not to learn how to align the chip on the board perfectly. My goal is to make enough money off of everything that I'm doing that I can take that process where I can make a mistake and have a machine take care of it. Like that's the idea, because the investment in the machinery to do this stuff, truly, the investments that I've made have paid off a lot. The investment in that ultrasonic cleaner paid off you know, at least 100, 1,000-fold by now. And the same is true with this. So, you know, if you're reading a lot of these forums or people are giving a lot of advice on what you should do, one of the things I suggest you do is actually look to see where they are. Look to see where the person who's giving you this advice on what you should or should not buy because you do or do not need this. Well, what do they do with it? What do you want to do with it? You know, if I had listened to the advice that a lot of these people were giving me, I'd probably be at a point where I'm reflowing one Xbox every 3 days and making like $150 and forced to move back in with my parents because I can't afford my apartment anymore. So, you know, the right solution is really going to be the solution that is right for your particular problem, for your particular setup. It's not going to be what somebody else recommends. And there are so many opinions on the internet where people are going to tell you what to buy, you know, what you need, what you don't. And there are going to be so many people who actually sound like they know more than you, but then you put them in front of the device, you put them in front of your workload, and they just break down and have no idea how to deal with it. And, you know, now you both look stupid because you listen to the advice of this person that can't help you, and that person talked all this crap, but they can't actually help you. So I'm not trying to sway your opinion as to what you should buy with this video, and I'm not really going to tell you what to buy. Again, my goal is to show you how the process works, how I do the process, so that hopefully, you know, you learn something from it. Hopefully you have a better idea of what you do want to buy and what you don't want to buy. Hopefully you have a better idea of what you're going to be good at and bad at, and you know what to expect. Because again, these videos where they're like 10, 30x and doing everything instantly with techno music at 360p, you don't really get to see much, and it really pissed me off, especially with this machine. I wanted to see one specific aspect of this machine. There's not one video on the internet of a ZM-R6200 or anything even remotely like it where you can actually like clearly see things or somebody points out things. It just drives me nuts. Anyway, I actually have to carry the board over to this desk now to work on it, and carry the soldering iron over because I used to have 2 soldering irons in this room and now I have 1. So there is one little thing that I knocked off that I have to fix. Oh, another thing. Some people may criticize the profile that I have because even after all the bars were liquidous, it was still running. Well, one of the issues, it's not about applying too much heat to the chip. Because there is a myth that, you know, you apply too much heat to this particular chip and you kill it. It's not about applying a lot of heat once. It's about when you're applying heat over and over and over. So if you have to run 2 or 3 profiles to get a job done, that's when you're actually going to be killing the chip. You're not going to be killing the chip when you run profile and you just let it dwell there for a little bit. This chip can go, you know, you can take that chip much higher than the temperature that I took it, and you'll be just fine. The problems are going to occur when you have to run 3 or 4 profiles in the same chip. That's when you wind up screwing things up on the board. That's when you wind up reflowing the LVDS mux and just fucking everything up to shit. The whole idea is to get it right the first time. And also with this machine, I can hit stop. There's a stop button. So having a long dwell time on the last step of your profile, what I've found, again, I'm going to admit here, I'm inexperienced as hell when it comes to setting a profile, and I'm also very inexperienced in terms of BGA rework. When it comes to motherboard repair, my specialty is circuit rework. My specialty is you spilled water on it and all these other functions are not working. In 20, 30 minutes, I will blaze through that board and fix all those issues. BGA rework, I will admit, is a weakness. I'm not going to pretend to be an expert at something I'm not. But what I've found in my limited experience is that when you run a profile, you can just stop it at the end if you see that everything's melted and it still has like 15 seconds left. You can just hit stop. But what you cannot do is hit start again and have it just leave off where it was done. That doesn't work. So it's safer to leave a little bit more dwell time on the end so that you can choose to stop it. Alright, so which resistor did I knock off? R8582. I got to reattach that. Again, it is embarrassing that I did knock a resistor off. It is seriously embarrassing. 2.37K. It is embarrassing as hell. But again, I say in this channel, the whole point is to not edit out the mistakes. So if I do something wrong or something doesn't go right, I'm not just going to roll another video because something didn't go right. This is the real world. This channel is supposed to be about the real world of fixing things. And in the real world of fixing things, sometimes you fuck them up a little bit. And people who will admit when they've done something wrong, who are not afraid to show their flaws, are usually, in my experience, more confident people. And they're also people that alright, so 2.37k, great, that's a completely not standard value. Alright, whatever, let's try to find something here. Where am I going to take this from? Here we go, this board is destroyed. Let's see if an 820-2850 has that resistor on it. Let's see, am I lucky today? Am I lucky? 2.37k. Boom. Come on, find me one so I don't have to walk outside. Find me one so I don't have to go outside. Here we go. Oh, thank God. Alright, R1950. So let's find that on this board and steal it and move it over to this one. When I say steal, I don't mean steal from a customer's. I mean steal from my pile like this. See? Trolls. My board. So, this was a profile board that I used to create profiles for the machine. Okay, so what resistor was I looking for? R1950. Okay, where is that? Here we go. It's right in the middle of nowhere, as I expected. Life is not meant to be easy. Okay, so LVD, it's right near the LVDS mux. Here we go, I see it. Alright. Time to kick some ass. Yeah, you're not gonna see in the microscope because I don't have that camera on. Sorry. This is not the fun part anyway. Trust me, you don't want to learn how to put the stuff back on when you knock it off. You want to learn how to not knock it off. This is not the part that you want to be. Oh, great. I got to change tips on this, so you're going to hear a beep for. Oh my God. Beeping, beeping, beeping. STFU already. The thing I like about this, honestly, I mean, for all the complaining I'm doing about this HAKKO, it's set up in a manner where you can take the tips off and put new tips on without using pliers. One thing that I hate is having to have pliers or something available to touch it, or even worse, this is worse than anything in the world, is having to wait, having to actually wait until it cools down to change the tip. No. No, I would rather burn myself half to death than wait till this thing cools down and change the tip. Alrighty, so. And my tweezers are here. I'm just going to steal this resistor that I knocked off by being a jackass. Where is the resistor? Resistor, here we go. Those sparks that you saw are from the paper tape that I should not be using to do this. Also, the IC that I actually moved got moved back on the second run of the profile. That's interesting. I'm just going to go over it once more because I don't trust that. That's actually kind of nice of the machine. I mean, the machine knew that it moved one of my chips off because when the old GPU dropped, it actually dropped onto an IC that sends 1.8 volts over into the GPU. So it knew that it did something wrong. And it corrected it. I mean, I think that's very considerate of the ZM-R. Don't you? I think that's very considerate of the ZM-R. I really do have to get some kind of rubber suction thing for that piece that picks the GPU up, the little nozzle in the middle. I don't get how that comes without that. I mean, maybe rubber would burn. Is there anything else that you could use there, though? Like, really, metal on metal? That's not going to suck a chip up properly. It's metal on metal. I mean, all of those other things that they use to pick up SMD components use rubber there or some type of material. And obviously the chip die has to be hot when it's picking it up. So, I mean, I know whatever material they're using there has to work. Anyway, who knows? Alright, so... let's see... One of the things I'm doing here that I shouldn't be is I'm actually putting the thermal paste and everything on. Usually you should just really just turn this thing on with the heatsink plugged in to see if it works, and then put the thermal paste on afterwards, because you're kind of jinxing it. It may not actually work. Your work may have failed, and there's no point in wasting the thermal paste and time on a dead GPU. But I like to do this. I mean, it seems weird, but I like to have a level of confidence that I know that my work is just worked, so that I'm not going to have to redo it. I know that it's going to work. I'm so confident that it's going to work perfectly that I don't even care if I waste thermal paste. I'm just going to go straight ahead and do it because I know that my GPU is good. You get this feeling in your gut when you know that something you did works, and that's what I have right now. I love that feeling. When you know you're going to turn it on and it's going to work, and you have no empirical evidence, you have no logical evidence, you just know. You know? Alright, let's get rid of this tape. And let's see what the other side looks like. I will show you that in a second. The video memory and the glue by it look miraculous, which is more than I can say for all the dust in this heatsink. Yuck. Yeah. There are a lot of people that say that you need to remove that stuff because it'll get messed up. I don't think you actually need to. I just think that the people who say that you need to remove the glue on the VRAM say that because they're so used to dealing with newbies who don't know how to apply the tape properly, who then wind up destroying it, and then blaming them for the bad advice on how to replace the GPU. So, I also forgot to remove some of the excess solder in that area. That will be next. I have a feeling that this thermal pad junk that they use on the PCH is actually more effective than their thermal paste. Just a theory, but... And I'm even going to put the speaker on there. If that's not cockiness, I don't know what is. And even the microphone, because I like this customer so much. You know, usually only get one of the two, especially if it's an A1278 and I feel like ripping your microphone while I'm removing your board. I've had a lot of employees do that one. Thank God they don't work here anymore. Yeah, I'm even going to put the speaker on. Now I got too much confidence. I got too much confidence. Alright. Okay, let's get the wick and remove some of that nasty ass solder that's stuck there. This is probably, I actually used the wrong wick. This is probably the worst wick you can use for GP. Like, look at how small this is. This is junk. This is truly junk. I shouldn't have used this for this job. Wait for the iron to heat up. Alrighty. Let's see what the board view says about those two places, actually. Okay, so the two things that are interconnected are actually both ground. At this point, I can safely say I'm ready to test the machine. So originally the issue with this was no video. So it turned on and it chimed, but you didn't actually see anything on the screen, whether you used an external or you used the internal screen. And let's see what we get now. Let's just turn the camera a little bit. Right. The other thing I'm going to show once I show you that the machine works is just how clean the video memory is when you don't use that tape and put it on the board. Because I Captain taped the tape to bare sections of the board instead of actually using the that aluminum tape's adhesive. Again, that adhesive is nasty, nasty shit, and it leaves nasty residue on the boards that you're not going to want to take off, that you're probably going to leave there, that the customer's going to see when they open their board, and they're just not. They're going to be pissed off that you left it there. Because it's gross. It's for, you know, you open your computer to upgrade the memory or put an SSD in there, and it looks like if somebody fucking spooged on it. That's not nice. I don't know why I'm plugging in all these things that I don't even need just to test it, because I really want to see that it works. It doesn't matter how many of these you do. It doesn't matter how many boards I fix in my lifetime. Every time I go to grab that MagSafe and plug it in, I get the biggest rush of excitement. Again, like replacing a screen, yawn, hard drive, yawn, data recovery, occasionally entertaining, but actually plugging in one of these to see that it works after doing stuff like this, it really never gets old. When you got, because even if when you believe in yourself, you still got that is it going to work, is it not going to work thing going on in another part of your mind. And Why am I plugging in the webcam? I don't need a webcam to see that the GPU works. Alright, let's get some fans in here. I'm gonna have to blow these out with compressed air. This is gross. The amount of dust in here is just disgusting. I know dust is gonna get into every design, but I don't get why. Like, you open a 2-year-old Lenovo and you open a 2-year-old MacBook Pro, and just the amount of extra dust and crap inside of here. There's just no reason for it. Alright, so it's about to chime. And like all 2011 boards, it turns on and then turns off before it turns on again. Okay, so we had no video before, and now the screen looks like this. Now, I'm not going to stay and run Firmark and all that other stuff and put the camera on there for this because, frankly, it's been a long day. This can get tested tomorrow. But the point is, the process that I showed you did work. The point is that everything that I've done, I haven't timed this video yet. It's probably been about an hour. I'm going to guess that it's been about an hour, somewhere between 45 minutes and an hour and 15 minutes. So this entire process should truly not take longer than 45 minutes to an hour and 30 minutes. It should not. This is including me fucking up and dropping something on the board that I shouldn't know, dropping the solder and wicking a resistor off. This is including the machine dropping the GPU on top of a chip that sends power to the GPU. I mean, I didn't exactly do things efficiently here. I didn't have the sucker that I needed to lift it up. I went to leave and come back for it. I had to move the soldering iron back and forth. I was moving this camera and talking the entire time. And in spite of everything I was doing, this entire process, from disassembly, this entire process, including putting everything back in the machine, is about an hour, truly. So hopefully you learned something, and also I forgot, I do have to show you this booting into the OS because it's when the driver kicks in that you're going to see if there's any GPU issues. But that's going to take forever because there's a mechanical Toshiba hard drive in here. Toshiba makes some slow-ass laptop drives. Once you get used to using a machine with an SSD, when you move back to moving something with a hard drive, it's not slow, it's broken. Like my friend always says that about this, you know, he's like, when he goes to open Safari and it takes 4 or 5 seconds, like that's not slow to him, that's literally, it's broken, it's just not working. I mean, my computer boots up in 9-10 seconds. I have a Linux machine with 2 Crucial MX100s, and it uses systemd as an init system. A lot of people on Slashdot would hate me for that, but, you know. Like, look at this fucking pinwheel bullshit. Oh, you missed the pinwheel. It was there for a second. Here we go. Oh, more pinwheel, more. Okay. You get the point. My GPU worked. My work is done. If you have any questions, post them in the comments. I will do my best to answer them as soon as I have the time. Please, for the love of God, do not call my business with questions on this video. We will troll you, we will hang up on you, we will ignore you. If you want to come and spend money here, by all means, we will give you as much time of day as we need. Even if you're just debating whether to spend money here, we will. But if you're calling with a do-it-yourself request, if you're calling to ask me what wick I used, private message. I don't want to stop my work to answer these questions, and to be honest, nobody else here does either. Alright, so as you can see here, I am loaded up. And I am done. I'm going to do my best to not show too much of the screen because I don't want you trolls contacting or calling any of the phone numbers or emails that show up on here. But point is, the job is done and the job worked. And as you can see, this entire job, from me taking that board out of the oven and burning my hands on it, to looking for the little suction cup tool to pick the chip up, to me putting the components back on the board that I misplaced, the thing that I've done here has taken about 45 minutes to an hour and 15 around there. And that's including me moving the camera around, including me screwing around with the tripod, including me taking the time to explain everything to you to make sure that you could see things with the camera angles, including me messing up some of it as I went. This entire process is something that you can do in about an hour when you have good machinery. And if I'm not even that good at BGA rework, I will admit it, I'm not that good at it, and I was still able to do it in this time frame. With proper machinery and knowledge and practice, you can truly get this down to a 40-minute process from start to finish. And if you have any other questions regarding BGA rework, regarding the machines that get used for BGA rework, if you have questions regarding the process, come over to advancedreworks.com/forum where we will discuss it with you. There are people there like me that are amazing at circuit rework that suck at BGA. There are other people there who are not that great at circuit rework who are great at BGA. So together collectively, there's a community of people who are all there to answer your questions, and we're answering them for free. All I ask is do not call my business phone number unless you want to be a customer. I think that's fair. If you want to call and say, I'm interested in getting a computer repaired, what is your warranty, how much does it cost, what's the turnaround, all that, by all means, I'm cool with that, but don't call asking what wick I use, don't call asking for the profile settings in the ZM-R, because when I pick up that phone, we pick up the phone here, we're usually picking up the phone with our, with our shoulder while we're holding adhesive with our teeth. We are multitaskers, and if you just don't plan on spending any money, just have the kind courtesy to send a message or comment on the video or post in the forum so that we can reply to it at your convenience. But if you have any questions about any of this stuff, advancedreworks.com/forum. I bought my machine from David of Advanced Reworks. He gave me great support with the machine when I bought it. He answered a lot of really dumb questions. I'm not going to joke with you. We had about 59 emails back and forth when I was talking about whether to buy this machine, and I was ignoring most of the advice and asking the same question over and over and over again. You need incredible, intense patience to deal with a nightmare customer like me, and if he had that patience with me, I'm sure that he'll have it with you. And there's also great resources available in terms of what you want to buy. So they sell chips as well. The chip that I soldered onto this board is a chip that I got from Advanced Reworks. If I had gotten a chip from L2 Computer to solder onto this board, I wouldn't have had to delete the file because it would not have worked. And overall, you could pretty much buy any of the machinery there, whether it's the reballing jigs, whether it's a 5 or whether it is a $7,500 ZM-R. You really can buy just about anything from the site. I don't get paid by Advanced Reworks. Truly, I don't. I'm just sick and fucking tired of getting screwed over, and I'm just so used to being screwed over as a part of my everyday life that when I actually don't get screwed over, I'm excited. I know that's sad. I know that I shouldn't expect to get screwed over. But that is where I am in life. When I don't get screwed over, I am actually excited. I'm actually happy that I didn't get screwed over. So like with this Scoto that didn't come with a thermocouple or a manual, I must have asked 6 times over the course of almost a year. I will even pay you for it. Just send me what it is. Just send me the stuff that I need. Never got back to me. I buy chips from L2 Computer. Here's $2,000. Just send me working chips. I just get a bunch of crap. Like I'm just used to being screwed over, and I don't want you to get screwed over by the same people who screwed me over. So when I find somebody who doesn't screw me over, who actually takes the time to help and explain things, I'm more than happy to rep them on this channel. I don't get paid by any sponsors. I don't get paid by any advertising revenue. Every single video that you see on this channel, even though that some of these videos are up to hundreds of thousands of views, do not have advertising, do not have any type of ad sponsoring of any kind. It is all legitimately free content that I'm not trying to make money off of. It is all legitimately free content. So that's it for today.